Something unusual is being revealed as humanity continues to look deeper into the universe. The James Webb Space Telescope was created to observe some of the most distant and ancient objects ever detected. Since beginning its scientific mission, it has allowed astronomers to study newborn stars, distant galaxies, enormous clouds of gas, and worlds orbiting stars far beyond our own solar system. But among all these discoveries, some observations are fascinating for a different reason. They make us stop and ask what we are actually looking at. Imagine pointing a telescope toward an enormous region of space and finding a landscape dominated by darkness, surrounded by extremely faint structures spread across unimaginable distances. At first, there may appear to be nothing unusual about it. The universe contains enormous cosmic voids. These are regions where galaxies are much less concentrated than in the surrounding areas. But the universe is not simply a collection of isolated galaxies. On the largest scales, matter forms a gigantic network known as the cosmic web. Galaxies and galaxy clusters gather along enormous filaments, while huge empty regions lie between them. These structures developed over billions of years. Gravity slowly pulled matter together, turning tiny differences in the early universe into the massive structures we see today. And this is where observations from Webb become especially valuable. By detecting infrared light from extremely distant objects, the telescope allows scientists to study periods of cosmic history that were previously difficult to observe. Some of the light reaching Webb began its journey billions of years ago. That means every distant object carries information about an earlier universe. A strange-looking region therefore becomes more than just a beautiful image. It can become a scientific clue. Astronomers can examine the positions of galaxies, their distances, their brightness, and the material surrounding them. They can then compare those observations with computer simulations and established models of cosmic evolution. One of the biggest questions involves dark matter. We cannot see dark matter directly, but its gravitational influence appears to play an important role in determining how ordinary matter is distributed. Where dark matter gathers, galaxies and other visible structures can eventually form. Where matter is less concentrated, enormous voids can develop. So when scientists encounter an unusual cosmic pattern, one possibility is that invisible matter is influencing the structure in ways we do not immediately recognize. Another possibility is that the observed features are connected to the enormous filaments of the cosmic web. These filaments can stretch across hundreds of millions of light years, carrying matter between denser regions of the universe. From our perspective, these structures are almost impossible to imagine. A single light year represents the distance light travels in 1 year. Now multiply that distance millions of times. That is the scale on which the universe organizes itself. And yet, despite the enormous size of these structures, their origins can be traced back to the earliest stages of cosmic history. The universe began in an extremely hot and dense state. As it expanded and cooled, matter gradually became organized under the influence of gravity. Over immense periods of time, stars formed, galaxies appeared, and larger structures developed. But scientists still do not understand every detail of this process. That is why new observations matter. A telescope does not need to discover an alien object or prove a completely new theory to transform science. Sometimes, simply finding something that does not behave exactly as expected is enough to open a new investigation. Researchers then ask whether the observation can be explained using existing physics. Could the apparent structure be caused by ordinary matter? Could dark matter explain it? Could distance or perspective make the feature appear more unusual than it really is? Could there be an issue with the data? These questions must be answered carefully before extraordinary conclusions can be made. And that is what makes the ongoing observations so fascinating. The universe is enormous, ancient, and filled with structures that developed long before Earth existed. Every new observation gives scientists another opportunity to reconstruct that history. Perhaps the strange patterns will eventually have a familiar explanation. Perhaps they will reveal something that current models do not fully describe. We simply cannot know yet. But one thing is certain. The deeper we look into space, the more clearly we realize that the universe still has enormous secrets left to uncover. And the James Webb Space Telescope is giving humanity an unprecedented opportunity to search for those answers. But the mystery does not end with simply seeing these distant structures. The real challenge begins when scientists try to understand what created them. Space can appear completely dark and empty, but darkness does not necessarily mean nothing is there. Invisible matter can affect its surroundings through gravity. Extremely thin clouds of gas can extend across enormous distances. Radiation can travel through seemingly empty regions, carrying information from events that happened billions of years ago. Together, these ingredients form a universe that is far more complicated than what our eyes can see. This is one reason the cosmic web is so important. On the largest scales, galaxies are not distributed randomly. They gather along enormous structures while huge regions between them contain comparatively few galaxies. These cosmic voids can be incredibly large. Yet even these seemingly empty regions are connected to the overall evolution of the universe. Matter flows through the cosmic web. Gravity changes its distribution. Galaxies grow and interact. Clusters become larger. And over billions of years, the entire structure continues to evolve. Webb allows scientists to observe different stages of that history. When astronomers detect extremely distant galaxies, they are seeing light that has traveled for billions of years before reaching the telescope. In a sense, the telescope is looking backward through time. That makes every distant observation valuable. Scientists can compare ancient galaxies with younger ones and investigate how the universe changed from its earliest stages to the enormous structure we see today. But unusual observations must be handled carefully. A strange pattern does not automatically mean that a new law of physics has been discovered. It does not immediately prove the existence of another universe. And it does not automatically reveal an unknown form of matter. Science requires evidence. Researchers need to determine whether an observation can be explained by known physical processes before considering more extraordinary possibilities. They also need independent measurements and additional observations. This process can take time. But that is not a weakness. It is one of the strengths of scientific research. Every possibility is tested against evidence. If an explanation fails, scientists move to another. If an observation continues to resist explanation, it becomes even more interesting. And that is where major discoveries can begin. The universe has already surprised astronomers many times. Objects once thought impossible have been observed. Thousands of planets have been discovered around distant stars. Black holes have been studied through the effects they produce on nearby matter. Ancient galaxies have been detected from a time when the universe was much younger than it is today. Each discovery has expanded our understanding while also creating new questions. The same could happen with future observations of unusual cosmic structures. Maybe the answer will involve the familiar physics of gravity, gas, and dark matter. Maybe scientists will discover that our current models need adjustment. Or perhaps observations will eventually reveal something genuinely new. At this stage, the responsible conclusion is simple: there is still more to investigate. And that uncertainty is what makes astronomy so exciting. We are studying a universe that has been evolving for billions of years, while our detailed observations of it are relatively recent. Humanity has only recently developed instruments powerful enough to detect extremely faint infrared light from the distant cosmos. The James Webb Space Telescope represents a major step forward in that effort. Its importance is not limited to one image. Its observations are building an enormous archive of information about stars, galaxies, planets, gas, and the evolution of cosmic structures. Some of those observations may confirm what scientists already believe. Others may force researchers to rethink parts of the story. And some may lead to questions that nobody has considered before. That is how our understanding grows. Not through one dramatic answer, but through thousands of observations that slowly reveal a larger picture. The universe does not give up its secrets easily. Every time we think we understand one part of it, another mystery appears.